Hi guys, welcome back to my channel wherein I solve the problems related to data engineering and machine learning. Um, so before I move ahead for my uh, new tutorial, and if you are watching this video and here for the first time, um, I would it would be really great if you could pause for a moment and consider subscribing my channel and liking this video so that I can make more of this tutorial and share my knowledge as we move forward, as that really helps me to invest my time as well as prepare the scripts and keeps me motivated. So the problem today, which we are going to solve, is related to fraud detection model, and this will be an AutoML feature which we'll use from Azure ML. And instead of so the main point here is I'm going to make use of an LLM tool such as Azure OpenAI to actually train a fraud detection model and doing it in a way wherein you save a lot of time on manual iterations. So, and instead of doing going through the traditional approach, I changed my approach a little bit to see how I can make a difference in saving the compute cost as well as saving my efforts and also creating a reliable pipeline. So I'll get started. So, so the main pain point, the problem which I'm going to solve today is, as you can see in the fraud detection models, and why did it occur to my mind? Because I think fraud detection model is one of the most popular models being used across the financial industry, mainly financial services. So as you can see, there are a lot of credit card transactions which are happening, and this is based on the Kaggle dataset, um, for which I will provide the links in the video description as we move forward. So what's happening is the main part is we need to identify the fraud transactions. But currently, what happens is in most of the scenarios when the model is poorly trained, and there is no proper feature engineering, and it leads to a real financial loss. And even though there will be a lot of legitimate transaction as well, more model is mostly seeing noise. Learns to predict not fraud most of the time because most of the data is focused on the legitimate transactions, hence not being able to detect the fraud transactions. And so it's like it may have a high accuracy, but it doesn't make sense and it's like a useless model. So what I'm trying to show through this tutorial is that you can make use of an LLM tool which will actually do the feature engineering for you instead of going through the traditional approach. So let me just show you the steps in traditional ML approach, although it's pretty basic, but again, I would love, I would just explain it in a brief. So what you happen is you have manual features, and it does take a lot of time for a data scientist. And if there is a class imbalance, then again, it is an overhead. And you just have a single model which you train in the same amount of time, and you do not have any explanation. It's like a black box. And as I said, it's a slow iteration, right? So it does take you a lot of hours to even train a single model. Hence, what happens is you have a low precision and high false positives. I hope you guys understand the confusion matrix. If not, I'll just put. Please go through the definition of confusion matrix to understand what high false positive is, what true positive is. So TP, FP. So there are like it's like a matrix. And what happens is regulatory risk and customer churn. So this is based purely on my research. I just try to understand. How can I make a difference through this video by just not explaining you the basic things, the fundamental things, or at an introductory level, which I always say through all my videos. So what I am trying to do is instead of doing the manual feature engineering work, which takes weeks, I want to make use of GPT-4 feature engine, and so that I have a better feature set. And similarly for class imbalance, I am using S mode balancing. So that model learns fraud patterns. Instead of using just training a single algorithm in the same amount of time, I make use of AutoML, wherein I am using three different models: XGB, which is XGBoost, LGBM, and the neural network, so that based on the AUC weighted target of 0.95 plus, I select the best model, and it is auto selected. And instead of black box decision, right, I make use of sharp explanations, which is for feature importance. And it is designing a high level, not a high level, production grade DP-100 data science solution. And slow retraining cycles are there, right? So, and it takes weeks per iteration. So and in order to, and what we can do through this, my solution is I can monitor the drift as well, and self-improving pipeline. So basically my focus is on like training the fraud detection model in such a way that it's not useless, and it does work for you, because of the amount of time you put into training the model, as well as the resources you put into training the model. So yeah, and I kind of like doing this part. So what happens is, what my main focus here is to that GPT-4 is actually replacing my weeks of features work. SMOT is fixing the imbalance. AutoML is actually running three competing algorithms simultaneously and picks the winner. And I think this end result is will be a REST API, which any like any company or like a small organization can use in real time to score an incoming transactions, right? So yes, so this is what I'm doing. And before I move forward for code and the scripts, so as I would say in each of my videos, they may not be at introductory level. So please feel free to pause and take your time to understand what I'm doing, and so that you are able to get the most out of the video. And I also try my level best, so that whatever video I'm making, or a tutorial which I'm doing, really helps people out there who are trying to learn Azure ML, and also getting started with machine learning. Um, because I think machine learning is pretty, it's just a hot topic like data engineering, and designing the pipelines for machine ML pipelines is something which I really like doing. So, yeah. And I'll move on to the actual part wherein I will be training a model. Actually, I'll be training three different models using AutoML, and I already have my scripts ready. It did take me a bit of time to even prepare the scripts, maybe like a good amount of time, as far as because I was preparing them. And yeah. So coming to the AutoML part, I'll just show you a little bit about AutoML. Why do you actually need an AutoML? And This is Azure Machine Learning Studio, and it is pretty cool. I think, and for this, what you I already in the last video. If you haven't watched, please go watch it. How I actually use the Gemini Pro um, LLM tool to improve on my machine Azure ML pipeline. But this one is more focused on a very common type of scenario, fraud detection, which is available in financial services industry. So I would like I already created a compute. I would just start running the compute. In the meantime, what I would do is I would just get my compute clusters ready, and so that I can run those scripts, and which I'll take you through. So let's create a compute cluster. So herein, by going into the compute instances, you can create a compute cluster for yourself. I know it's pretty basic, but again, these basic things really matter. And I would just choose the cheapest one because I don't want to spend too much money on compute, because this is the main component which eats up, which contribute, which increase the cost. But and the best part is by using an LLM feature engine, you avoid retraining, you avoid that time spent on getting the right feature engineering, which again, the people who do ML are aware of it. It takes a bit of effort to even design, get those right features. Yep, let's create this. I would just say this is for fraud com- compute something, and minimum number of nodes, maximum number of nodes. Maximum, I would just say two, right? You have insufficient subscription to scale. All right, let's idle seconds before it calms down. Maybe make a 200. At least it gives me a bit of time, right? So this is their minimum number of nodes has to be one, right? Wants me to change the name fraud compute, something like this. I can create the cluster now. I wanted to the time I set is because at least you need 200 seconds, otherwise it will be just starting and restarting, which again wouldn't be nice. And so let me show you. I also have another compute wherein I will run my Jupyter. So this one, if you I run start this now, and I mean, you do the same at VS Code level, which I'll show you how I actually do at the VS Code. Maybe you can find a better way of doing it. If you do, please comment down in the video that this can also be, and this can be the other way of using it, and maybe yeah, that would help other viewers as well. So there can always be better ways of doing things, and if you really think at some part of the video or at some point which I'm doing, please do comment. Maybe that can I can also get to know about it. Yep, and this is actually I'm opening my remote compute instance, connecting to the remote server. So I was trying to execute this register components.py file. So yeah, let's explain what I'm actually gonna do. Through a diagram. So let's see. So this is how my video will be structured, and this is are the steps involved. First of all, I'm setting up my Azure ML workspace. As you can see, I was creating my cluster. Then I have already downloaded and registered the fraud dataset. I'll rerun the code. It's not a problem at all. It just updates the version as I've shown you in the last video. Then I'm actually building the GPT-4 feature engineering component, and then building the pre-processing component with S mode and running the full pipeline in Azure ML. And then I have my auto ML job, which is actually training three different models. Then I'm registering and deploying the best model. And then I'm connecting to GitHub because I can publish all my files onto a public repo, which I will share down in the video description. So it's like an end-to-end solution, which shows you an end-to-end ML pipeline creation, and which again, it's not bad. So as you can see, your compute instance is ready now. I can click on Jupyter Lab and let me see whether my compute cluster is succeeded. And what I would do is I would use this compute cluster. I'll show you all the files which I have. So as you can see, these are the environment registration file. So you register your environment using Conda, and so you actually register your LM environment and preparation environment. Then you register your components. So you register the LLM components and the preparation components. So this is actually AutoML job. So I have created a pipeline which is there. What I would do is I'll just name this as fraud compute. So fraud compute, um, and then it will actually it will actually run the yes. So what I have actually done is, as you can see this data, right? I already downloaded the data credit card CSV. You can see the sample data set in here, right? I'm not sure whether it will show you delimiter because it's a vast data set. So maybe that may be the issue, right? So it's like a vast data set. It is actually being just wait for a bit. Maybe we can see the data. And this is also available in here. As you can see the data, right? So because the compute is actually connected, the notebooks actually pop up over here. As you can see, credit card CSV, right? So I'm actually running. It's a vast data set, and what I can do is I can download and see the file, and because I know it's a huge file. So what I will do is, it's not a huge file though. Why is it so? It's like an empty file, whatever. So and I can also see my data assets in here. So folder is created. It's like a workspace, web store, file. Uh, so yep, explore, number of files. Maybe it has the inherent file in it, right? So yeah, credit card, then you have, there are multiple train.csv. Yeah. So details. Uh, uh, so what is it? View latest. Explore. We explored it, right? So credit card.csv file size is actually a smaller size, which kind of makes me think that I may need to rerun. So what is data set? Uh, so, so you can download the data set again using this. So what I can actually do is I would not need to run. So can you see that I can see everything in here? So I can see my files on my local, and I can just directly run it from here. So basically what I'm doing is, not sure where is it showing, right? So this is actually showing on my local file. What I would do is I'll see that I have everything. CD dataset, ls. Then what I do is Python download dataset.py, right? I will rerun this dataset again. So yes, there will be a bit of hiccups. It's all right. What you can do is you just pick this up. I'm just trying to show you the easiest way, right? Because there will be a bit of hiccups. It's all right. For example, you create a IPNB file. What you do is you paste the code in here and you run this. Initially it did throw up an error, but again, it's easier to run the IPNB files because you are actually running in the cells as compared to running a full Python file, but I'll still be using a combination of both. So it has actually occupied 100% of CPU memory, which is crazy. Maybe it is a huge data set, I have no idea. So it has like 284807 rows, but it's still downloading it, right? It does fail. So what I would do is, so I'm just trying to show you that you will have a bit of hiccups. You will be stuck at few things. That's why I created this video, so that what I would go is, I'm still failing at this. It's still failing to download the data set. So, yep. So what I do is, just let's see. It says I was using an old code. Yes, I was. Let's let's run this again. Because I would love to check first whether it does have because 121 byte doesn't seem to be the right sort of data. So I mean, although also what you can do is you can manually download the data from the Kaggle website and upload to this directory. That's up to you, right? Let me check. This time I go to notebooks, I refresh this again. So what I would do is I would just try to register this. So this is my way to register my data set onto my data sets and this cell. So what you would see is it will register my data set to my there is an update data set.